Hi, welcome to my video on proofs with quadrilateral kites. Proofs on kites. Definition of a kite. A quadrilateral with only two pairs of adjacent sides equal and no parallel lines or segments. So here we have the shape of a kite. E, A, B, C is a kite. E, A, B, C is a kite. It has AB equal to BC. It has, AB equal to CB and AE equal to CE. AE equal to CE. These are marked. So this is a kite, and the longer diagonal is EB and the shorter diagonal is AC. So in relation to that, let's look at a couple of proofs, and you can pause the video and do these proofs if you wish. Here we go. Prove the longer diagonal of a kite bisects the angles of the kite. So we're given that ATHM. So ATHM is a kite. Make that an A. ATHM, the longer diagonal bisects. So we have a kite, so that means that MT is the longer diagonal. And we got to prove that the longer diagonal bisects the angles of the kite. So we got to prove that angle 3 equals angle 4. And we also got to prove that angle 1 equals angle 2. So the longer diagonal bisects the angles. Okay, here we go. Now, how are we going to, let's see. We have a kite, so therefore there's going to be, so that means that AT is equal to HT, AM equals HM, and MT is equal to MT reflexive. So the triangles are congruent, so the angles are equal to CBCTC. So therefore, it bisects the angles. So here we go. Number 1, we have that ATHM is a kite, as given. Number 2 is that AT equals HT and AM equals HM. Definition of a kite, because a kite has two pairs of adjacent sides equal. And we have MT equals MT, common side to the two triangles. So that means the two triangles are congruent. So the triangle AMT is congruent to the triangle ATH. AMT, AMH go the same, because I got to go, A goes with A, M goes with M, and T goes with T. So AMT is, so AMT is HMT. I almost did that one wrong. So AMT is HMT, because 3 goes with 4 and 1 goes with 2. So M got to go with M and T got to go with T. So that's correct. So that's an SAS congruency. And as a result, angle 3 equals angle 4, angle 1 equals angle 2. CPCTC, PC, just a little tiny bit in my writing this morning. Corresponding parts of congruent triangles are congruent. So that means if we want that the MT bisects the angles, definition of a bisector, or we could say angle bisector. So we could say 3 is equal to 4, 1 is equal to 2, or we could come up with that the longer diagonal bisects the angles. Okay, next one. Again, pause the video if you wish and see if you can do this proof. The longer diagonal of a kite is perpendicular to the shorter diagonal. So we have a kite here, so X, Y, W, V is a kite. And we have XW is the longer diagonal. And that means that YV is the shorter diagonal. And that be the case, we have to prove it's the perpendicular bisector. So we're going to prove that X, Y is the perpendicular bisector of the shorter diagonal, which is YV. And in order to prove the perpendicular bisector, we need to prove that it forms a right angle, and we need that it forms 2 equal parts. So again, how are we going to do it? Well, we're going to prove, let's see, I have to get a right angle at 1 and 2, and I have to prove that OY equals OV. So OY and OV are in the triangles YXO and VXO. So we have that side equals that side because we have a kite. We have angle 3 equal to angle 4 because the longer diagonal bisects the angles of the kite. And we have XO equals XO common, so these two triangles, YXO is congruent to YXO is congruent to VXO by SAS congruency. Therefore, 1 is equal to 2 CPCTC, and because 1 and 2 are equal, that means the lines are perpendicular, because perpendicular lines form congruent adjacent angles. And we have YO equals VO CPCTC, therefore we have a perpendicular bisector because it forms a right angle and these two segments are equal, OY and OV. So I got the proof laid out. So X, Y, W, V is a kite, and that's a given. Number 2, we have that X, Y equals XV, definition of a kite, that adjacent sides are equal. Number 3, we have angle 3 equals angle 4, the longer diagonal of a kite bisects its angles. That's the proof that we did out there. And number 4, we have XO equals XO, and that's a common side. Therefore, we have the triangles congruent. The triangles are Y, O, X, and VOX, and that's side, angle, side, congruency. That means that angle 1 is equal to angle 2, CPCTC, and I can also say that OY equals OV, and that means that XO is perpendicular to YV, which is the shorter diagonal, and the reason if two lines meet to form congruent adjacent angles, then they're perpendicular. If two segments meet or intersect to form equal adjacent angles, then the segments are perpendicular. And number 8, so we have they're equal, so that means that XW bisects YV, definition of a segment bisector, and the last statement that XY is the perpendicular bisector of the perpendicular. That's a V there. I wrote it. Just got to be careful. Definition of perpendicular bisector. So that proof is handled okay. Notice if you want to prove a perpendicular bisector, you have to prove that there's right angles or two adjacent angles formed by two lines are equal, then the lines must be perpendicular. Or we could have said because they're equal, there forms a right angle and therefore a perpendicular. And we got the two segments equal, so we have a perpendicular bisector. So let's look at a couple more, some practice. Practice means pause the video and see if you can do these proofs before I do. Okay, hopefully you have the diagram done, you had the proof done if you wish. Here we go. We're given that KITE is a kite. KITE. This is a kite. Angle 1 equals angle 2. Mark them. Angle 3 equals angle 4. We'll mark them with 2 strokes. And we have a kite. So let's go this and put all the givens. Let's put all the givens in the first step. Again, check with your teacher if you're going to do them individually or you can put them in one step. I'm just putting them in all in one step to save time writing them down. Now we have a kite, and in a kite has the adjacent sides equal, so that side equals IK equals EK and TI equals TE, but we're trying to prove that VITE is a rhombus. So VITE is a rhombus. And when we have a rhombus has all sides equal. So I had to prove that all the sides are equal. So this KI and KE are not involved with the rhombus. So what I'll do is say that this side equals this side. So TI is equal to TE. Definition of a kite. Kite has adjacent sides equal. Now, why did we give 1 equals to 2? So 1 equals 2 means that IV equals IT. And because 3 equals 4, that means that EV is equal to ET. And that's converse of the ITT, which is, because we have two angles of a triangle equal, then the sides opposite those angles are equal. Because we have these two angles, 3 and 4, equal in this triangle ETV, that means EV equals ET, converse of ITT. Now we got IT, which is right here, is equal to IV, and we got TE, which is here, is equal to EV. So that means, if we put all them together, so TI is equal to TE is equal to ET equal to ET equals EV and equals VI. So we have all the sides. Just check. We got VI, EV, TE, and TI. They're all equal, and that's the transitive property. But it's the transitive property twice. So what we're saying is that IT is equal to IV, IT is equal to TE, so that means TE equals IV as once. Now we got TE right here. TE is equal to IV, ET is equal to EV, so IV is equal to EV. So that's transitive property twice. So ask your teacher if you're allowed to say that. And now we have that VITE is a rhombus. And that's by definition of a rhombus. A rhombus is a quadrilateral, 4 equal sides. So that proof is done. Now we have one more to do in this video. Given that MITF, we have this figure with all sorts of triangles going all over everywhere. So we have MITF is a kite. So MITF is a kite. We have AI equals HF. We got to prove that MATH. So MATH is a kite. So the inside one is a kite and the outside one is a kite. So because we have a kite, then I have this side equals this side and this side equals this side and this kite. Now I need to prove, because MATH all the way around is a kite, I need to prove that this side equals this side, and I also got to prove that this side, AM, equals HM. So I got to get AT equals HT, and I got to get MA equals MH. So how are we going to do it? How are we going to put it together? Well, there are several ways to do it, but one of the ways that I'm going to do it is I'm going to do it by see if I can get a pair of triangles congruent. Can I get a pair of triangles that has AM and HM in it? Or can I get a pair of triangles? Can I get MTA and MTH? But I have to use the inside kite first, use their properties to get at the larger one. So here we go. I'm going to go with, I'm going to use the kite, and I'm going to say that MI and MF are equal. The definition of a kite, MO equals MO, and I'm going to say that angle 1 is equal to angle 2, because of bisector, so the triangles are congruent. Okay, that gives me, that's one way I can get IMO and FMO congruent. Or I can say that because this is the long diagonal of this kite here, MITF, I can say that MT is perpendicular right here and bisects. So I could go with the 1 and the 2, get congruent triangles and work that way. But I'm going to go with, put that 3 and 4 there. And I'm going to go on the other side and get the other triangles later. So I'm not going to use this 1 and 2 here. I'm going to use these two angles, 3 and 4. So here we go. And I'm going to get these two, I'm going to get, say that 3 is equal to 4. And I'm going to get MO equals to MO. And I'm going to say that IO equals IF, CP, or because the long diagonal bisects the shorter one. And if I take IO and add on IA and take OF and add on FH, then I'll get AO equals HO. So this triangle AOM will be congruent to HOM. So that'll give me these two equal. And I'll do the same on this side, only I'll use the angles 5 and 6. That's how I'm going to, that's one way to do it. So here we go. MITF is a kite. Given. Number 2, that means that MT is the perpendicular bisector of IF. The long diagonal is the perpendicular bisector of the short diagonal. That's a proof that we did just over on the previous page. And number 3, that means that because it's perpendicular to angle 3 is equal to angle 4, because perpendicular segments form congruent adjacent angles, and also that OI equals OF. Definition of a bisector. The long diagonal is the perpendicular bisector, short one. So we have angle 3 is equal to angle 4. That means that we can say that MO equals MO. Common side of the triangles. Number 6. Now we can take OI and add, I have to say the givens first though. I have to say my givens. I didn't do my givens, so I'm going to put the given that AI equals HF in the given. So now because I have it up here, I can take the OI and the AI and take the OF, add on HF. That's addition. You're adding the segments together. And as a result, we can say that AO equals HI plus IO, and HO is equal to OF plus FH. What we're saying is that AO is this segment, is made up of AI plus IO, and HO is made up of OF and FH, and that's the segment addition property. And hence, what we have is that the AI and OI are right here, OF and HF are right here, so that means that AO equals HI by transitive. Again, those two are right there, those two are right there because they're equal. There they are equal, so that means AO equals HO. So that means I have now my triangles AOM and HOM are congruent. So what we have is, we have this side MO, we have this side AO with angle 3 is equal to 4. So those triangles are congruent by SAS congruency. That means we have AM equal to AH, AM equal to HM. Better be careful. AM equals HM, and that's CPCTC. And now I got AM equals HM, so now I need to get AT. So the same will apply for the other side. I have angle 5 equals angle 6, so now I'm going to prove AOT is congruent to HOT by using 5 and 6 angles. These two angles equal, and that's because of, I'm going to say, perpendicular lines. So that's same as number 3 reason. There it is there without writing it down. Number 12 is OT equals OT. Again, that's number 5. Common side. It's quicker. You could say the same as number 5, or you could just say common side. So notice now I have AO equals HO here. I have angle 5 equals angle 6. I have OT equals OT. So I have triangle. So I have AOT is congruent to HOT, and that's side AO, angle 5, and OT, so that's an SAS congruency. So that means that we have AT is equal to HT, or congruent to HT. That's CPCT. Congruent parts of congruent triangles are congruent. CPCTC. And notice now we have a kite. So we have MATH is a kite. If I can spell kite correctly. Sometimes my brain don't work right. That's kite, K-I-T-E. And why? By the definition of a kite. Definition of a kite. What's a kite? A kite is a quadrilateral with two pairs of adjacent sides equal, and there's no parallel lines. So that's a kite because of, where's number 10? Right here, AM equals HM, and number 14. 10 and 14 have the sides, adjacent sides equal. So that's some proofs on the quadrilateral, referring to the quadrilateral kite, which has two pairs of adjacent sides equal and no parallel lines. So that brings us to the end. And if you like my video, click on the like button, the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.